Welcome back to the deep dive. Okay, I want you to imagine something for a second. You're using your computer, but we effectively turn off the monitor. Well, not the whole thing, but just the part with the pretty icons, the mouse cursor, all those colorful windows you're used to. We're stripping it all away.
Right, to look at the engine underneath.
Yeah.
The black box. It's funny, how many people use a computer their entire careers and never actually see the computer, just the interface painted on top?
And that is exactly where we're going today. We are digging into the Class 2 notes for system administration. The topic is configuration and text file commands. And honestly, looking at this, it feels like that moment in a movie where the hero learns the magic sword isn't just for swinging wildly. There's actually a technique to it.
That's a really good analogy.
Yeah.
Because, if you're just clicking buttons, you're a passenger. This material, the shell, the environment, manipulating text, this is where you start to become the mechanic, maybe even the architect.
So here's our mission for this deep dive. We need to decode the shell, what it actually is, because notes make a key distinction there. Then we'll figure out how to, decorate this digital home to make it livable. And then we're opening the toolkit. Grep, sed, tail. The tools for processing massive amounts of data without ever touching Excel.
Exactly. It's all about efficiency. And the Unix philosophy, which we'll definitely get to. But first, we have to talk about where we're even working.
Let's start there, the shell. To most people, it's just that scary black window with a blinking cursor. But the notes define it very specifically. It's an interpreter.
Exactly. It's not the computer, it's a translator.
Yeah.
You type a command, the shell interprets that text, and then it tells the operating system what to do. But here's the kicker, and the notes highlight this with that unscientific shell popularity chart.
Huh.
There isn't just one translator, there's a whole flavor war going on.
I loved that chart. It felt like sports team stats. And Bash is, it's clearly the heavyweight champion. It just crushed the poll with 52% of the votes.
Oh yeah, Bash the born-again shell.
Yeah.
It's the standard.
Yeah.
It's the default on almost every single Linux distribution you'll find in a server environment. That's why it wins. It's not necessarily that it's the quote-unquote best at everything, but it is everywhere. You sit down at a random server in a data center, you're almost certainly speaking Bash.
But then you've got the runner-up, Zesh, at 24% and Fish at 12%. So why the fragmentation? If Bash works, why are people going out of their way to install these others?
It really comes down to user experience versus compatibility. Bash is utilitarian. Zesh and Fish, they're more like luxury cars. They come with better autocomplete themes, spell checking for your commands, all that stuff right out of the box. Zesh even became the default for macOS a few years back, which explains a big chunk of that 24%.
So if I'm a student or a new sysadmin, do I just pick the one that looks the coolest?
Well, you can. For your personal laptop, sure. But the notes give a pretty strong warning here. The syntax for scripting, the automated programs that run your servers, it differs between them. If you write a cool script in Fish because it was easy, and then you try to run it on a production server that only speaks Bash, it's just going to break.
Right. You don't want to learn a dialect that nobody else actually speaks in the real world.
Exactly. You master Bash first. It's the lingua franca of the Linux world.
Okay, so speaking of mastering the environment, the notes spend a lot of time on this difference between a login shell and a non-login shell. I have to admit, at first this felt like splitting hairs. Why does the computer care if I'm logging in versus just opening a new window?
It feels technical, but it is so crucial for troubleshooting. Think of it like this. When you first connect to a server, say with SSH, that's a login shell. The system has to build your entire world from scratch. It reads these very specific configuration files like .bash profile or .profile. It's setting the foundation.
Okay, so that's the heavy lifting at the start.
Right. But now let's say you're already logged in. You're working. And you just pop open a new terminal tab to check a log file. The system doesn't need to rebuild the entire foundation.
It just needs to paint the walls.
Exactly. That's a non-login shell. And it reads a completely different file, usually .bash arche.
I think the analogy in the notes was about leaving your house versus just rolling up your sleeves at work.
Yes. The login shell is putting on your coat and the boots and commuting. The non-login shell is you're already at your desk and you just open a new folder.
And the danger here, I'm guessing, is you put your settings in the wrong file.
That is the classic rookie mistake. You put a cool alias in your .bash profile. You log in, it works. Awesome. An hour later, you open a second window to use it, and poof, it's gone.
And you're sitting there yelling at the screen, but it worked 5 minutes ago.
Precisely. Because that second window never even looked at your profile file. It only looked at the .rc file. That's why most sysadmins put their configurations in .bash rcheck and then just have the profile file load the rshave file. It keeps things consistent.
So these config files, .bash art and .bash profile, what are we actually putting in there? This gets us to the interior decorating part of the notes, the environment variables.
These are basically the invisible wires that control how everything in the shell behaves.
Yeah.
The notes list a few obvious ones like USER, which is who you are, or PWD, where you are. But the one that matters, the one that causes probably 90% of the why isn't this working headaches, is path.
The all caps path. I think everyone has seen that command not found error at some point.
And they immediately think, oh, the program isn't installed. But a lot of the time, it is. The shell just doesn't know where to look for it.
So what exactly is the path then?
It's literally just a list of folders separated by colons. When you type a command like Python or grep, the computer doesn't scan the whole hard drive. That would be way too slow. It only looks inside the folders that are listed in your path variable. It checks the first folder. Nope. Checks the second one. Nope. Third one. Yeah, there it is.
So it's like a scavenger hunt list.
It is. And the order really matters. If you have two different versions of Python installed in two different folders, the shell will run the one it finds first in your path. That's a huge gotcha for developers.
The notes mention using printenv to see these variables and export to set them. Why do you need export? Why can't I just say variable value?
This gets back to the shell being a program itself. If you just set a variable, it only exists in that one specific shell window. It's local. But when you run a script, that script actually starts a tiny subshell, a child process, to do its work.
And parents don't automatically share all their secrets with their kids.
Not in Linux, no. Not unless you export it. The export command basically says, hey, take this variable and make sure any child processes I start can see it too. If you don't export your settings, your scripts will be completely blind to them.
That is a critical distinction. It's the difference between a sticky note on your own monitor and a company-wide memo. Before we move on from configuration, I have to bring up else scholars. The notes call it convoluted, which I think is a very polite way of saying it's a total mess.
It is convoluted, but don't underestimate its power. When you are staring at a terminal for 8 hours a day, any little thing that reduces cognitive load is a huge win. Having directories just show up in blue and executable files in green lets your brain parse the screen instantly without reading every single character. It's not vanity, it's usability.
Fair enough. Okay, let's shift gears. We've set up our digital house, we've decorated the walls. Now let's talk about the sharp objects. Segment 3 of the notes, the danger zones.
The command line is a force multiplier. And you have to remember that it multiplies your productivity, but it also multiplies your mistakes.
First up, a history file, .bash history. It remembers everything you type so you can recall commands. Sounds super convenient, but the notes raise a massive security flag.
It is a huge, huge risk. Think about how many times you might connect to a database or a secure server. You might be tempted to just pass the password right on the command line, like dampy, my password 123.
Right, just to get it done quickly.
If you do that, that password is now saved in plain text in your history file on the hard drive. Anyone who gets access to your account or just walks by your unlocked computer and hits the up arrow can see it.
So the rule is never, ever type a password as a command line argument.
Never. A well-designed program will prompt you for it interactively. You know, when the cursor just blinks and you type and nothing shows up, that does not get saved in your history.
Got it. Okay, other danger zone, wildcards. The asterisk. It means everything.
It's incredibly powerful. You know, ls.txt shows you every single text file.
But the notes have this disaster prevention hint, and I have a feeling this comes from some very painful personal experience.
Oh, every sysman has a story about this. The command arm.
That's remove everything.
Everything. And if you're in the wrong directory, you say you think you're in some temporary folder, but you're actually in, I don't know, the system boot folder.
Oh, no.
And you run ARM, there is no recycle bin. There is no undo. It is just gone.
That is genuinely terrifying.
It is. So the tip in the notes is so simple, but it is life-saving. Always test your wildcard with else first. If you want to delete a bunch of files, type ls.tmp first. See exactly what the shell is about to grab. If that list looks correct, then you hit the up arrow and change else to arum.
Look twice, delete once.
It is the only way to survive.
All right, let's move to what the notes call the meat of this class. This is where we get into the Unix philosophy. The idea that small is beautiful.
This is really the core concept that makes Linux so different from, say, Windows. In Windows, you tend to have these huge monolithic applications that do everything. In the Unix world, the philosophy is to write a small program that does one thing, and does it really, really well. And crucially, make sure you can talk to other programs.
And they talk to each other using pipes, right? That vertical bar character.
Correct. A pipe takes the output from one command and feeds it directly into the input of the next command. It's like building a little factory assembly line on the fly. You just snap these small tools together to do something really complex.
The notes give us a whole toolbox of these small blocks for Class 2. Let's do a quick fire round. First up, WC.
WC is word count, but it also counts lines and characters. It's the fastest way to answer a question like, how many user accounts are on this system? You don't count it by hand. You just pipe the user list into WCCL.
Simple enough. Next, head and tail.
These just let you peek at the beginning, head, or the end, tail, of a file without opening the whole thing. But the real star here, and the notes call this out, is tail-f.
The -f is for follow, right?
Yeah. Imagine a web server log file that's getting written to hundreds of times a second. If you run tail-f on that log, your terminal just stays open and prints new lines as they happen. You're watching the matrix code scroll by in real time.
It's like the server's heartbeat monitor.
Exactly. If that scrolling stops, you know the server's in trouble. It is the first thing you do when you're troubleshooting a live issue.
Okay, next up is the big gun, .grep.
grep is your search tool. It finds patterns in text. If you have a 10,000-line log file and you need to find every line that contains the word error, you use grep.
And this is where regular expressions, or regex, come into play.
That's the power user level, yeah.
Oh.
grep is great with simple words, but with regex you can ask for something crazy like, find me any line that starts with a timestamp, has 3 numbers, and ends with the word fail. The notes also mention useful flags like XUV to show everything that doesn't match, or XC to just give you a count.
That seems like a deep rabbit hole to go down.
It is, but it's a genuine superpower.
All right. Moving on to sed, the stream editor. How is this different from just opening a file in a normal text editor?
Sed is for editing text programmatically. You're not opening a file and typing. You're giving a set of instructions like, go through this data, and every time you see the word alpha, I want you to change it to beta.
But the notes have a big warning here. Cress works on the stream, not the actual file, right?
By default, yes, which is the safe mode. It reads the file, makes the changes in memory, and spits the result out to your screen. The original file on your hard drive is untouched, but there's a JI flag for in place. If you use that, Sado overwrites the original file with the changes.
And I'm guessing that's where things can go wrong.
Very wrong. If you mess up your sedi command, you might accidentally replace every single letter E in your system configuration with a blank space. And that would be, well, a very bad day.
There's a slide in the notes here titled, Thank You, Microsoft. It's about line endings. This feels like a very specific, long-held grudge.
It's a clash of civilizations, really. Linux uses a single character, the line feed, or LF, to mark the end of a line. Windows, for historical reasons, going back to typewriters, uses 2 characters, carriage return plus line feed, CRLF.
Why on earth does that still matter in 2026?
Because if you write a script on your Windows machine in Notepad, it secretly puts those invisible carriage return characters at the end of every line. Then you upload that script to a Linux server, and the Linux shell sees those extra characters, and it freaks out. It tries to interpret them as part of your command.
So you get these totally bizarre errors that make no sense.
Exactly. You get command not found on a command that looks perfect to your eyes. It's the invisible characters sabotaging you.
And the fix for this headache.
The notes list 2 utilities, Dust Unix and Unix Tudos. They're little conversion tools that just strip out or add those extra characters. If your script is failing for no apparent reason, running Dust Unix on it is often the magic fix.
Okay, so we have our tools. Now this is the part you should really be paying attention to because we're moving into the Lab 2 tasks and the homework roadmap. This is where you actually have to apply everything we just talked about.
Right. Time to stop talking about the hammer and actually start building the shelf.
First up, the lab section introduces virtual terminals.
This is a really cool feature that a lot of people forget about. Even if you don't have a graphical interface, a Linux machine isn't just one screen. It's actually running multiple virtual consoles at the same time.
And the notes say you access them with CTRL, ALT, and then the function keys F1 through F6.
Right. So you could be logged in as yourself on F1, running some long download. Then you can hit CTRL, ALT, F2. You get a fresh login prompt. You can log in as the root user to check some logs and just flip back and forth between them. It's like having multiple tabs in a browser, but at the console level.
So let's look at one of the Lab 2 tasks. This is a great puzzle that really tests that Unix philosophy. It asks students to use head and tail together to view just lines 100 to 125 of a file.
It's a classic interview question. You can't just tell the computer, show me the middle. You have to think in terms of that data stream.
So walk us through the logic there.
Well, if I want lines 100 through 125, the first thing I need is the top chunk of the file that includes those lines. So I'd use head to grab the first 125 lines.
Okay, so now you have a stream of data that is lines 1 to 125.
Right. But I only want the bottom part of that chunk. So I take that output and I pipe it into tail and tell it to just give me the last 25 lines.
I see. So you trim the bottom off the original file with head, and then you trim the top off of that result with tail.
Exactly. Head minus n 135, tail minus n 25. It forces you to think about data as this flow that you can shape and filter.
Another task involves using the which command.
Which is simple. It just tells you where a command lives on the file system. If you type which Python, it might tell you uswrbin Python. This ties directly back to that path variable we were talking about. It tells you which folder in that scavenger hunt list actually won.
And then there's a tricky one. Find a command that modifies characters in a pipe. The prompt hints that it's like Z, but for single characters.
They don't name it, but they're absolutely pointing students towards TR, which stands for translate. It's a tiny, perfect little tool for things like swap all lowercase letters to uppercase or delete all the colons from this text. It's pure, small is beautiful philosophy.
Looking briefly at the syllabus, just to wrap up the logistics. Instructor Dave Reed has a very clear policy on attendance.
Attendance is required, but health comes first. I think that's a very post-2020 mindset.
Yeah.
He basically says, if you are feeling unwell, let him know. Don't come in and get everyone else sick just for a participation point.
And perusal.
That's the collaborative reading tool. It seems like the goal is to solve the classic problem of students not reading the textbook. You have to go in and actually comment on the text, ask questions, and reply to other students. It kind of turns reading into a group activity.
Finally, the big picture here. The final project.
Right. Everything we talked about today, the variables, the wildcards, grep, this isn't just trivia for a quiz.
Yeah.
The final project for the course is to build a bash script that automates server management. You're building a tool that checks things, verifies commands, and sends alerts.
So you're not just learning these commands to pass a test, you're learning them so you can build a robot that does your job for you.
That is the ultimate goal of a good system administrator. If you have to do a task twice, you automate it. And you can't automate it if you don't understand how sed handles line breaks or how the path variable really works.
So what's the big takeaway here?
I think it means we're crossing a threshold. The shell gives you direct, unfiltered control. It can be intimidating because there are no guardrails. Remember Marm Tarum? But the efficiency you gain is just unmatched. You stop fighting the interface and you start controlling the machine.
We're finally opening the hood and getting our hands greasy.
Absolutely.
Here is a thought I want to leave you with today. We talked a lot about things that are hidden. Hidden files that start with a dot, background processes, invisible line-ending characters. As a sysadmin, so much of your work is designed to be invisible to the user. If the server's working perfectly, nobody even knows you exist.
That's the paradox of the job, isn't it? You only become famous when things break.
So is a silent system a working system? Or is it just a ticking time bomb that you haven't checked with TLF yet?
That is the question that keeps good sysadmins up at night.
Something to think about before you hit enter on your next command. Thanks for diving in with us.
See you in the shell.